Hey guys, welcome back to one more video on the channel. In this video, we are going to solve a really interesting question. So the question goes like this. There is a quadrilateral with side lengths A, B, C, D. And this quadrilateral can be inscribed inside a circle. Alright? This can be inscribed in a circle and it can also be circumscribed in another circle. Alright, so now the question is find the area of such quadrilateral in terms of side lengths. So you have a quadrilateral ABCD, something of this sort. A circle can be inscribed inside it and a circle can also be circumscribed around it. So this is the given information. Now you're asked to find out the area of this quadrilateral in terms of the sides of the quadrilateral. So as simple as that. So now let us proceed with the step-by-step solution. So we have, by the way, I saw these questions in one of the exams that I have taken when I was in my +1. Alright, so first thing, the first information that is given to us is that this can be inscribed inside a circle. So let us say you have something like this. Alright, A, B, C, D. Now what information do you have from this figure? So we know that sum of opposite angles is 180 degrees. Alright, because it is a cyclic quadrilateral. Sum of opposite angles is 180 degrees. This is the information that we get from this particular thing. Alright, now if this is alpha, this is 180 minus alpha. Let us say this is beta, then this is 180 minus beta. Alright, something like that. Now one more information given is the same quadrilateral can be circumscribed about a circle. So A, B, C, D. So there is a circle that lies inside it. Pardon me for the figure, it doesn't look like a circle, but let's say this is a circle. So let us say this length is x1. So then this length is also x1. So that is the theorem in circles. So if you have some circle like this and if you draw tangents from an external points, so then this particular length and this particular length will be same, correct? So let us use that fact and let this be x2, then this is also x2, x3, x3, x4, x4. Alright, so now here let us say AB is equal to A, this is B, this is C, this is D. Now your A is simply x1 plus x4 and your B is x1 plus x2. Similarly, your C is x2 plus x3 and your D is x3 plus x4. Alright, so this is what we have. Okay, now the question asked is we have to find out the area of the quadrilateral. So let us redraw the quadrilateral. Alright, so then this is A, B, C, D. A, B, C, D are your lengths. So if we draw a diagonal like this, then your area of the quadrilateral will be area of triangle ABD plus area of triangle BCD. Alright, so let us say this angle is alpha. So then this angle is 180 minus alpha. We already discussed it here. Alright, so now what is area of triangle ABD? Area of triangle ABD is half into A multiplied by D multiplied by sine of included angle, correct? Plus area of triangle BCD, that is simply half multiplied by B multiplied by C multiplied by sine 180 minus alpha. Half BC sine 180 minus alpha. So this is your total area of the quadrilateral. So that is simply half AD sine alpha plus half BC. Sine 180 minus alpha is simply sine alpha. So you get half AD plus BC multiplied by sine alpha. So this is your area of the quadrilateral, but we still have this particular sine alpha term. So we have to somehow eliminate that. Okay, let us see how that can be done. So we somehow have to find out the value of sine alpha. Let us do that. How can we do that? Let us say this length is L. So if you apply cosine rule in triangle ABD, you will get L square is equals to A square plus D square minus 2AD cos alpha. And similarly, if you apply cosine rule in triangle BCD, you will get L square is equals to B square plus C square minus 2BC. Cos of 180 minus alpha is minus cos alpha. So here you will get plus cos alpha. Now this is also L square, this is also L square. So equate both of them. A square plus D square minus 2AD cos alpha is equals to B square plus C square plus 2BC cos alpha. So you have A square plus D square minus B square minus C square is equals to 2 times BC plus AD cos alpha. So your cos alpha is simply A square plus D square minus B square minus C square by 2 times BC plus AD. Okay. So now let us pause at this moment and go to the beginning of this solution. So here we wrote all these things. A is equal to x1 plus x4, B is equal to x1 plus x2, C is equal to x2 plus x3, D is equal to x3 plus x4. Now if you check A plus C, you will get x1 plus x2 plus x3 plus x4. Similarly, if you check B plus D, you will get x1 plus x2 plus x3 plus x4. Correct? So sum of the opposite sides is same. A plus C is equals to B plus D. So let us write that here. A plus C is equals to B plus D. We have this thing as well. Understood? So now, this can be written as A minus D is equals to B minus C. Square it on both sides, you will get A square plus D square minus 2AD is equals to B square plus C square minus 2BC. Now you get the terms A square plus D square minus B square minus C square is equals to 2AD minus 2BC. See how beautiful this is. So we have generated this particular thing which sits here in the numerator as this. Okay. So now your cos alpha becomes really simple. It becomes 2 times of AD minus BC divided by 2 times of AD plus BC. So this and this will get cancelled. Now here sine alpha is very easy to find out. Sine alpha is, the denominator is simply AD plus BC. The numerator will be square root of AD plus BC whole square minus AD minus BC whole square. So what will you get when you solve that? So this looks like x plus y whole square minus x minus y whole square. So you will get 4 times of xy. Correct? So here you will have 2xy and here you will have 2xy, 4 times of xy. So you will get simply square root of 4 times of x is AD, y is BC by AD plus BC. This is your sine alpha. So put this in the area formula. So this one, half into area is equals to half into AD plus BC times sine alpha is 2 times root of ABCD divided by AD plus BC. So this and this gets cancelled. This 2 and this 2 will get cancelled. A is equals to square root of ABCD. See, such a beautiful and clean result you have at the end. So this is a very beautiful problem. So that's all for this video. I hope you have got something to learn from this. So initially, since we know the quadrilateral is concyclic, we concluded that the sum of opposite angles is 180 degrees. And then since this quadrilateral can be circumscribed about a circle, so we wrote these 4 results. And from this we concluded that A plus C is equals to B plus D. And we went on to find the area of the quadrilateral. And here, this is the major step. You take this and generate this particular term like the numerator of your cos alpha, and then simplify to get the nice value for your sin alpha. So if a quadrilateral is if a quadrilateral can be circumscribed and inscribed in a circle, the area of such a quadrilateral is root 𝑎𝑏𝑐𝑑, where a, b, c, d are the sides of the quadrilateral. So if you like the solution, do not forget to give this video a thumbs up, share it with your friends, and subscribe the channel for more such content. If you have any queries, comment section is the way to reach out to me.